Today we will talk about mathematical functions and operators in MonetDB. And before doing some calculations, first we should make sure that our value is of the proper data type. If it isn't, then we can use either cast function or convert function to transform some other data type to number. For example, we can transform this string to double, or we can transform this boolean to small integer. So if I run this, I will get only numbers, and those numbers will have data type that is defined inside of these functions. Next, we can see that we can use traditional mathematical operators in MonetDB. So we can use plus sign, we can use multiplication, division, so on. We can notice here that if we divide decimal number with 2, we would get the correct result. We would get 2.5. But if we divide two integers, then we would get another integer as result. So the result will not be 3.5, but just 3. And this here is operator for modulo. So if we run this statement, then we can see that 8 modulo 3 will return remainder of 2. Now, besides using these traditional operators, we can also use functions. So for each traditional arithmetic operator, we have some function as a counterpart, and we have this function for modulo, for addition, division, multiplication, negation, and subtraction. So we can run this, and we would get the same result we could get with traditional mathematical operators. I will now clear my screen. We have already saw that in MonetDB we can use logical operators, and we can calculate, for example, select true and false. Besides that, instead of using true and false, we can use 1 and 0. So I can type select 1 and 0, and I would get the same result. Now, this is how we can use a logical operator on numbers 1 and 0. We will now jump to this web page, and we will see here two binary numbers. And binary numbers are made of ones and zeros. And for each of these pairs of ones and zeros, we can apply a logical operator. For example, 0 and 1 will return 0. Or we can use, for example, 1 or 0 will return 1, because we're using OR logical operator. So this is a kind of an operation that we can actually apply on integers, because each binary number can be presented as integer, and we have special bitwise operators that will be applied on two integers, and that will give the result just like in this table. So if this is one integer, this is second integer, we will connect them with a bitwise operator. We have bitwise operator for AND, for OR, for XOR, and for NOT, and we would get the result by following this logic. Let's now go back to terminal to see some examples. Here I have two integers, and they are connected with an operator that is bitwise AND. So this is bitwise AND. We also have a function, and this will return the result of two numbers that are the same, because it doesn't matter if we are using operator or function. We also have operators and functions for bitwise OR. Here they are. We have operator and function for bitwise XOR. Here it is. And we also have an operator and function for bitwise NOT. And this would be the result. I will now jump again to this web page. I will go down here to show you something more. Here we have one binary number. If I use this operator, and this operator is bitwise shift to the left one position, I will move this one here to the second position. By doing that, instead of having number 1, I will get number 2. So number 1, if it is shifted one position to the left, it will return 2. So this number will be doubled. If I move it 2 positions, for example, from position 1 to position 3, I will actually double it twice. So instead of having 1, I will not get 2, I will get 4. And if I move it 3 times, in that case, I will get 8. So with each change of position, I will double it. And the opposite of this bitwise shift to the left operator, I have bitwise shift to the right operator, and with it we will move a figure to the right side. So instead of being on the fourth position, now it will be on the third position. And each of these movements will half my number. So instead of having 8, I will get 4. If I do it on 4, so if I am on the third position, I will move to the second position, so I will get 2. So each movement will do the opposite. If this operator is doubling my number, this operator here will half my number. And for that, we have functions in Monet. First function is this. So this is bitwise left shift. And this will first double 1 to 2, and then will double 2 to 4. So the result will be 4 because we are moving our figure 2 places. And we also have right shift. So this time I will right shift 8 one position, so I will half my number. I will now clean my screen. If we want to calculate minimum or maximum value in Monet database, in that case we have functions SQL max or SQL min. Besides those two functions, we can also use greatest to calculate maximum or least to calculate minimum. So if I run this, I will see which number is smaller and which one is bigger. For calculation of a root, we have two functions. First function will calculate the square root, and the second function will calculate the cube root. So if I run this, I will get the correct results. But what if I want to calculate the root of a higher order? Well, for that, I will jump here to this web page, and here we can see this identity here. We can use that identity to calculate a root of a higher order by using power function. So I'm using power function, and power function will calculate how much is 16 to the 1/4. So this is 0.25, 16 to 0.25 will actually calculate the fourth root of a 16, and that will be 2. And we can see that here in the terminal. I will now clean my screen. Next, we will talk about exponential and logarithm functions. And exponential function is function power. We have already saw it. So how much is 2 to the 3? Well, the result will be obviously be 8. But what if we know number 2 and we also know number 8? How to get this number 3? So we need an inverse function, and that inverse function is logarithm function. We can use it like this, and this function will return 3 for arguments 2 and 8. In this case, we have used 2 as a base number. But beside that, we can also use so-called natural algorithm. In that case, base number is Euler number. That number is approximately 2.71, and we can type it like this inside of power function, or we can use exp function. So when I run this, I will get how much is Euler number to the 3, and we will get this result. Now previously we saw that we can use log function to calculate inverse value, and it is the same with exp function. In that case, we just have to type log win one argument, or we can use its synonym ln. So when you run this, we would get number 3, because this is an inverse function of this exp function. Just like with Euler number, we have specialized functions if base number is 10. If base number is 10, we don't have to type it explicitly like this. We can just use log 10 function. So if I run this, I would get number 2. And we also have log 2 function, which will use number 2 as a base. So we can use it like this. I will now clean my screen. Each real number is between two integers, and to calculate those integers, we can use floor and ceiling functions. We have an argument of 7.55, and the first integer below is 7, and the first integer above is 8. If argument of floor and ceiling function is an integer, then both functions will return that integer. So floor of 7 will return 7, and ceiling of 7 will return also 7. We can notice that instead of ceiling, we can use the short form ceil. Next, we will take a look at truncate function. So this is truncate function. With this function, we can restrict number of decimal places. Our argument has 3 decimal places, but if I want 0 decimal places, I will get only -5. If I want 1 decimal place, then I will get only -5.6, and this is what I will get if I want 2 decimal places. If we want to restrict number of decimal places, we can also use round function. This is round function, and we can notice that if the number ends with 5, then we will always round up. So if we have 5.5, we will get 6, and if we have this number with 3 decimal places, then we will end with 5.56. But it is the same as when we have negative number. So for negative number, we will not go up, we will not go toward 0. Instead of that, we will again get the value that is bigger absolutely, and then we will just apply minus on that absolute value. So we are always rounding up as an absolute value. Then we can use these truncate and round functions, but I will use second argument as a negative number. So what will happen now? In that case, we would get zeros. So both functions will return a 0. And at the end, we have a function that will combine truncate and round. So this is that function. So how this function works? Well, this is our number. First, I will apply this second argument. So I will remove this number 6. So number 6 will be removed. We only then have 5.54. And then I will round that number to 2 decimal places. So the result will be 5.54. But in this second expression, I will first truncate 0 decimal places. So this will be my number. And then I will round this number to 2 decimal places. So the result will be 5.55. So I will get different result because of this truncation argument. So I will run this, and we can see how we get different results based on this second argument. I will now clean my screen. If we want to get a random number, then we can use run function. This function will return a number between 0 and 2 billions each time when it is called. And each time it will return a different number. So if I run this, I will get here this number, and in the second call I will get this number. We can provide an argument to this run function. That argument is so-called seed value, and this seed value will make this run function to always return the same value. So each time we call it with the same seed value, it will return the same number. So this is that number in this case. Next, we can also use absolute function. So absolute function will always return a positive value of a number. Next function is sign function, and sign function will just return a sign of a number. So if this is negative number, it will return -1, and for positive number, it will return 1. And we also have this alpha function, and this is some special function that is used for astronomy. This function will compute alpha expansion of theta for a given declination. I don't know what is that, but I know that is used in astronomy. I will now clean my screen. The last set of functions we will talk about are trigonometric functions. First, we have a function pi, and that function will return the value 3.4. I will now jump here to this web page. We will go down here until we reach an image of triangle. Here we have one right triangle. The smallest angle inside of this triangle is this one here. It has 36 degrees. If we want to transform these degrees to radians, then we can use radians function, and that will return 0.64 by using this formula. We can also do the calculation in opposite way, so we can use decrease function from radians value, and that will return 36 degrees by using this calculation here. Next, we have sine function. So this function will accept the size of this angle in radians, and it will return the ratio between B and C. Here on the image we can see that we have B side of triangle divided by hypotenuse, so we will get 0.6. Cosine of this angle is A divided by C, so we are dividing A by hypotenuse. Then we have tangent from that angle that will return the ratio between b and a. So we are dividing b with a. And we have cotangent of this angle that will return a divided with b. We are dividing a with b, so that will return 1.33. We also have inverse functions. For example, arcsinus will accept this value and it will return the size of this angle in radians. Arccosine will accept this value, this ratio, and it will return again the size of an angle. Arctangent will accept this value and it will return again the size of this angle in radians. And arctangent can accept only one argument, or it can accept two arguments. So these two arguments are also acceptable here. And when we divide them, we will get 0.75, so the result will be the same. We also have some hyperbolic functions. We have hyperbolic sine. So if we use this function on this argument, we will get this value by using this formula here. Hyperbolic cosine, we'll use this argument here to return this value by using this formula here. And at the end, we have hyperbolic tangent that will accept this argument to return this value by using this formula here.